Since I forgot to start the recording today for class, I will go ahead and redo the example that we did in class today with showing a little bit of filtering and sampling to be able to conduct an ANOVA for a set of data. All right, so in this particular wine prices file, we've got the data for different data for France, US, and Greece. And then we also have point values assigned to particular wines. So those range, in this particular file, they range from 81 up to 95. And then we have price values associated with a particular wine that has a particular point value from a particular country. So what we're going to test with this particular analysis of variance is, does the price of the wine depend on country? Does the price of the wine depend on point value? And for the interaction piece, is there interaction between price of wine based on point value coming from a particular country? So we're going to test all of those three with an analysis of variance, but to do that, we need to do some sampling. So I'm going to turn on filtering. So you can get to filter in a couple of different places. You can either do it from the home menu under sort and filter, and you see filter there, or you can do it under the data menu where you see filter here. Usually when I turn on the filter, I make sure that I am actually on the row that I want to filter by. Sometimes Excel is screwy if you've got multiple pieces of information around. If you're not on the column, or excuse me, if you're not on the row where you actually want to do the filtering, it'll start trying to filter in a weird place. So just in general, I try to make sure that I am up on the row that I want to filter before I hit the filter button. Notice it gives you drop down boxes again to be able to filter by different things. So the first thing I'm going to do is I'm going to get some random samples from France. So I'm going to hit the drop down and just select France to get French values. Now I want to divide these up into categories by points. Again, the categories I'm going to use are going to be 81 to 85, 86 to 90, and 91 to 95. So first I'll get an 81 to 85 sample. So I'll just click off the 81 to 85 on here and hit OK. These are the values that I want to, these are the prices from this group that I want to try to get a random sample from. So notice though, when you filter, it eliminates rows out in your data that you can't see here. But if you try to sample off of this, it might try to sample from blank rows. So it's always better to take this and copy it over to a new sheet before trying to do your sampling. So I'll just highlight that row 10 there. I'll hit Control-Shift down arrow to get to the bottom. I will copy. I will open up a new sheet here, and I will paste. All right. So let's say I want to get a random sample of size 20 out of here. So I will go to Data Analysis. I'm going to go down to Sampling. I need an input range, so I'll go over here, start at C1, hit Control-Shift down arrow. I want 20 samples. In this particular case, I'm picking 20. You can put whatever you want in there. And I can define where I put my output range. I'm going to put it up at the top here at E1, just so I can see what my sample is. All right, so if I go back up to the top, here is my random sample of size 20 coming from the price data. All right, so these are going to, remember when we do our analysis of variance, we've got the table that we think of make for the row factors and the column factors, but in each cell of that table, we have multiple observations. These 20 values are what's going to go into that one cell that's defined by France on the row and 81 to 85 on the column. I'm going to do that in a new sheet. So remember, for analysis of variance, we have to include the labels in our input for the analysis of variance. So I need to put labels in here as well. So across the first row, I'll put the 81 to 85. I'll put France. I'll put France on in the column over here for A. Now I'll put US in here as well, but I'm going to go ahead and copy my data over first so I know where the US goes, so I don't have to really count down to the row that I need. So I'm going to paste that into this cell. Here's France, here's 81 to 85. All of these observations are in that one cell. Then I know my US one's going to go here. I could do Greece, but just for time purposes, I'm not going to go through the Greece one as well. But you would do the same kind of thing. You would just put it down as a third row. All right. Let me go back here and delete this out. I'm going to use basically sheet 2 here is going to be my scratch work. All right, so back up to the top. Let's refilter. Instead of doing 81 to 85, let's do 86 to 90. Let's copy these over to sheet 2. And let's use our data analysis tool again to get a random sample of size 20. Now, I copied this over. This was filtering from 86 to 90. I have no reason to expect that from 86 to 90 would have the same number of data points in it as 81 to 85. So I want to make sure here with my input range, I go back and re-put in the whole list. I don't want to use the same list that I had from 81 to 85 because I don't know that they're the same number of values in there. All right. Now I'll go back up to the top here and grab these 20 and then move those over to sheet 3. And there are 20 values there. All right, now let's just repeat the same process here for the other one for France. So back over, refilter, copy, and paste, and resample. Again, remembering when you resample to go back over and reselect your data. And notice again, this one went up by about 170 values that were in the list of data. All right, so now I'll grab these and put them back over into my table that I'm going to conduct the ANOVA on. All right, so now I've got, again, just to reemphasize, here's my 3 column categories by point values assigned to the wines. This is my 1 row associated with France. For the ANOVA on Excel, it's very important that you have the same number of sample data in each individual cell of the table. All right, so since I put 20 in the first one, I got to make sure I put 20 in the rest of them. Now I want to do the exact same thing for the US. All right, so back over to sheet 1. And then I'm going to refilter by US. So click off France, click on US. I want to leave it as 91 to 95 because I got to copy it anyway. And resample. And grab. And put over here. All right. That was the 91 to 95 again, so I want to make sure I put that in that same column. Go back over here and do the same thing to get these last 2. This is why I'm not going to do Greece. Put these last 2 in here because it just takes a while. All right. So back over, back up, refilter, and copy and paste. Sample again. And grab the sample and put in table. one more to go to fill out this particular row. Oops. And I do enjoy all the notifications coming in through email. Let's go over here and paste again. And over here, re-highlight your cells. And go up and highlight this. And finally now we get to fill in the last cell. All right, so now let's do our ANOVA. So we go to data analysis and we want to do, in this case, with replication. Our input range here, again, remember that we want to make sure that we start in the upper left-hand corner and highlight absolutely everything that we have. Okay, and it's important to do labels and all. All right, make sure that's included in your list here. So going back up to the top, it's important to have those labels across the column and the labels in the row. It's also important to tell how many rows are in each sample. So we knew that we took sample sizes of 20 to get these columns. Significance value you can set, and where you put the output you can set. I'm going to put the, oops, I didn't mean to do that. So let's redo this. Okay. Output range. Let's do the here. Here. All right. Okay. There we go. All right. Pardon me. So we've got the different summaries by different values here. So we look down at the bottom, though. This is what's telling us about our null hypothesis thing. So again, the first thing you should always check is for interaction. So again, the interaction here is saying that the price would depend on point value and country at the same time, more so in one country than another. That's what interaction would say in this context. The price value would depend on the value for France in points, more so than, or less though, so than the US in the points. But what we're seeing in this particular one is that in this hypothesis test is we don't have enough evidence for that. So we would not reject the null hypothesis that there is interaction. The book's notation for that is the H sub AB. So we do not reject H sub AB here. We don't have enough evidence for that. There's not enough evidence to say that the price varies more by point value based on France versus based on the US, that there's not some sort of interaction in each cell. All right, so we look at the rows now. Is there more of an effect on the price based on which country you are? That's what row effect would be here. And again, we're not seeing that. We would not reject here. So this one would be a do not reject H sub A. That's what again, that's the book's notation for row effect. So basically what this is saying for our purposes is the mean price for wine in France based on these point values is not necessarily different than the mean price of wine in the US, again, based on those samples. Okay. And you could do that, you could test that out by using those samples and doing a hypothesis test like we had before for just differences of means. So up here, you could see that here are your two differences for means here. And then based on those variances, would there be enough evidence to say that you would reject? And that's exactly what we're seeing here, is that there's not enough evidence to reject that. All right, however, if we look at the columns, there is a column effect. At least there's evidence for a column effect, I should say, because we certainly have enough big F value and a small P value associated with that. So what that is saying is that the price does depend on the point value. And you can kind of see that, especially in this last one. There's probably not enough evidence to conclude across the columns here that you have a difference in individual columns. But if you look at down here, here's your column data. There's 40 in each column. These two, probably not enough evidence to conclude that those two are different based on the data, but certainly this one is going to be different than the other two, just given the value there. It's likely that this one's different than the other two for as far as mean value goes. So there is a column effect there. It really is mattering what column you are in to tell whether or not there's a price difference, what the mean of the prices would be. So we can see that based on the data here. So again, here, this would be your row effect. Is there a difference in those means? Probably not. Well, maybe not. I guess is probably more of an accurate statement than probably not, given that p-value, but maybe not. And again, if you conducted a hypothesis test based on this data, on whether or not those means are actually different, probably not going to happen. You could actually go back and do that, right? You've got a sample mean, you've got sample variances, you've got sample sizes based on the rows. You can test that hypothesis. Here, there's one of these column means is probably different than the other ones. We can see that here. And then here they were saying that there's not any evidence of there's not evidence of definite interaction of cells. So as you go across the point values for France, how it changes by point value for France is not significantly different than how it changes by a point value for the US, is what the interaction piece would say. So anyway, that's the short version of what I lectured on today, because I forgot to hit record when I did the lecture, but this is the nuts and bolts of what we did. So this should help you with especially the last problem on your homework. And then, as I mentioned at the end of lecture, I'll probably be assigning your take-home test probably Wednesday after you turn this homework in, and your take-home test will be like what your homework is like, except that instead of just doing it for section 7.4 through 7.6, you'll do it for the entire chapter 7. We will probably start chapter 8 on Monday, but that won't be on this take-home test. We'll be doing that one on the next take-home test. My guess is what we're probably going to do is we'll do chapter 8 and have a take-home test on that, and then do chapter 10 and at the end of the semester, and that's probably all we'll have time to do. That does get us covered through everything that we need to cover for this particular class, but that's probably what we'll end up doing for the rest of the semester. So anyway, bring questions that you have on Monday. Feel free to reach out if you've got more questions, but hopefully this will give you a good example of what I expect you to be able to do for the last problem on your homework.